Hello everyone, welcome to our presentation. Today we are excited to introduce ExpRes, a cutting-edge social media platform built using REST TV technology with enhanced security, resilient and content traceability. I'm Purva Khadke and joining me today are my team members Devavrat Singh Bisht, Kunjal Agrawal, Priyadharshini Ganeshkumar and Vrushali Harane. Next slide. So previously, communication platform lacked robust accountability and traceability, making it difficult to ensure transparency and trust. Message could be lost or misinterpreted, and tracking interactions was often unreliable. With Express, we prioritize message traceability through blockchain, ensuring every communication is transparent and accountable. For example, when A sends a message to B, which is inappropriate, and B sends it to C, and afterwards, if the message is getting reported, then the user A will be banned by our system. Additionally, past systems struggled with fault tolerant message retrieval. If the system failed, users lost access to their chat history. Now, with REST-DB's fault-tolerant system, Express ensures seamless access to chat history, even during system failures. Together, these features create a robust environment that fosters trust, reliability, and effective communication. Next slide. Let's talk about Express, a decentralized blockchain-powered social media application. Express stands at the intersection of cutting-edge technology and a seamless, user-friendly interface. It is designed to enhance the overall social media experience while ensuring privacy, security, and transparency. One of the standout features is better user reporting and traceability. With a blockchain backbone, every interaction and report can be traced, ensuring that users can hold each other accountable for their actions, while also providing a transparent record of all engagements. Express also offers a robust chat application, enabling secure, reliable, and real time messaging between users. The system ensures smooth and uninterrupted communication. Finally, transparency in posting and engagement is a key feature. Every post, comment, and interaction is recorded transparently on the blockchain, ensuring that there's no hidden manipulation or censorship. This transparency builds trust among users and fosters an open and honest platform for all. Next slide.
The tech stack combines modern, efficient technologies to build a scalable and resilient social media platform. React.js ensures a responsive UI, while Fast API and Python powers high-performance, secure backend development. MongoDB manages user data and authentication, while ResilientDB handles message tracing, transactional integrity via GraphQL. Docker streamlines deployment, ensures portability and scalability. Together, this tech provides a robust foundation for a feature-rich application.
This is the architecture of our application. So our front end consists of React.js. It consists of functions like user registration, user login, chat between the users, post management, search friend request, add friend request, view chat history, and viewing the profile details. Whenever user hits these functionalities, a call goes to Fast API, and the Fast API connects it to the backend. In the backend, we use the power of RESTDB to save user posts and user chats, and we use MongoDB to store user information, post engagement, and message transaction IDs. Next slide. So this is the sequence diagram of one of our functionality, send message. So whenever a user sends message to another user, a WebSocket connection is established between them. And with that, we also hit a fast API called send message. The send message fast API then hits our backend where we have an encryption algorithm to create sender private key, public key, and receiver public key. We use these keys to formulate our GraphQL request. In the GraphQL request, we will save data related to the sender username, receiver username, and the and a transaction ID. So if it's a first message, the transaction ID will have some default value, and if it's a forwarded message, then transaction ID will have the value of the previous generated transaction ID of that message. Then the GraphQL request will hit the REST-DB. The REST-DB will generate a unique transaction ID, and that transaction ID will save in the MongoDB with other user details, and send this transaction ID back to the front end. This transaction ID will be later used for reporting the message. Next.
Now let's dive deeper into the two main functionalities of Express, which the first one being the forward message functionality. So this is similar to whatever was explained in the previous send message sequence diagram, but with slight changes. So when a user hits the forward message button, a trigger to send message fast API is sent, and then the fast API basically sends the message to the hash algorithm, which will generate the cryptographic keys, and then we create the asset as a GraphQL request, which will include transaction ID, message content, sender and receiver username. So how is it different from the previous one-to-one send message is that since the message here is being forwarded, it's not a new message anymore. So here in the asset, the transaction ID will have the ID of the original message. And then this is sent to RESTDB, and so RESTDB again generates a unique transaction ID for the forwarded message. So here another thing to note is that the unique transaction ID that's generated by RESTDB is different from the transaction ID that's stored in the asset. So yeah, next slide. Now let's look at the report message functionality. So when a user clicks the report message button, a trigger is sent to the report message fast API endpoint along with the transaction ID of the message that's being reported. So this is again sent to RESTDB, and since we saw in the previous sequence diagram, the asset of the that's stored in the RESTDB will contain the transaction ID of the original message. So here RESTDB will basically return the transaction ID of the original message back to the fast API, and from there that transaction ID and the corresponding user information will be sent to MongoDB, and there in the MongoDB we simply set the block flag to be true, which indicates that the user has been blocked, and then fast API sends a confirmation back to the user interface. So this whole functionality serves the purpose of traceability and accountability in Express. Now let's dive deeper into the demo of Express.
Okay, so now that we know what Express is, let's see what the application actually does and what all features the Express has. So this is our home page, which consists of the title of the project, along with the information of the team members and the contact footer. So we have a user registration form. I'll register a sample user. And we've added validations for all the fields. So the registration is successful. Once the user has been registered successfully, he or she will be redirected to the post section, which is one of the main functionalities of Express. Here they can post content. So I'll just post some sample content and you can see my post, We also have a like button wherein if you like the post, you can add it. If you feel the content is inappropriate, you can report it. And these are all the posts that I get to see under the post section. Now I'll show you the login feature as well. So I'll log in as Dev, which is one of our existing users. So the login is successful. Now, once the login is successful, the user can send friend requests or accept friend requests via the search friend as well as the profile section. So under the search friends section, I can search for people or my friends and send them requests. So I'll just search for my friend here, and if he or she is available, I can just add them as my friend. Now I'll show you the accept friend request functionality. So currently I've logged in as Dev. I have also opened the application in a different tab, and I'll send a friend request from Alice. So this is Alice's profile, wherein I've logged in as Alice from a different window. I'll send a friend request from Alice to Dev. So I'll just search for Dev. I'll add friend, and now I should be able to see the friend request under Dev's profile section. I'll also send a friend request from Jason, which is one of our existing users. Again, I've logged in as Jason in a different window. So I'll send a friend request from Jason to Dev. I'll search for Dev from the search friend section. Now going back to my login, I am this Dev. I can see the two requests that I sent from Alice's profile and Jason's profile under my profile section. I can accept the request or I can reject it. Currently, I'm accepting the two requests. Now here, again, we have the post section, so I can post content from my profile as well. I'll just add a sample post. So here, under my profile section, I get to see the posts that I've already made. And under the post section, you get to see all the posts available under the ExpRes application. Here, you'll get to see the Dev's posts basically. Now, once I accepted my friend's requests, the followers and the following count gets updated. As you saw, I just posted some content, so the post count has also been updated. I'll then click on the followers list, and then I get to see two buttons message. So these buttons will redirect me to the ExpRes chat application wherein I can chat with my friends Alice and Jason. So opening chat with Alice. So I'll just say, hello, Alice. And here we have two buttons. The red one being the report this message, this icon being forwarding, wherein I can just forward a message or I can report a message. Now I am currently logged in as Dev and I sent a message to Alice. I will send a message from Alice. I can send a message from Alice to Dev as well. Now, since both of them are friends, I get to see Dev's name under the friends list. So I have already received a message from Dev. I'll say, hello, Dev. And I should be able to see the same message. Under this profile, I'll have to reload. So yeah, I get to see the message. I can report it if the content is inappropriate. And as we are reporting the message, we can also report a post. So if I feel the post or the content that has been shared by this user, Rudy John, is inappropriate, I'll just click on the report button. It is grayed out and the post will also be deleted. I'll just reload it and show it to you. So the post has been gone by Rudy John. I'll also show you that the user has been banned. So I'll search for Rudy. If I click on this, it gives me a pop-up saying that the user has been banned. So this was about our application ExpRes. And we have also created a blog on Medium.
So this is the blog that we have created with all the details of the design, the functionalities, and everything. And let's quickly take a look at the future scope. So there are many points that we jotted down, but one point that we wanted to highlight was about the reporting mechanism. So currently in our implementation, if a user reports a particular user or a message or a post, it just gets removed without any further investigation. So this can be improved by introducing some admin UI and some sentiment analysis and go through some levels of investigation. And then if it's actually offensive or inappropriate message, then we can remove instead of directly blindly removing it. So this is one future scope that we wanted to highlight. And there are many more, and it's all highlighted in our blog. So that's about ExpRes, and thank you.